Another factor, though, is where symbolics might not be appropriate, is that we can actually override JCL statements. And what we would do in that case is we would add inline JCL that would identify the DD name that we want to override or that we want to specify a different value for. And this is what we would use if we did not have a symbolic, or if we didn't even have a DD statement in some cases for that to be specified. We can use the proc step name, the step name, and the DD name as the vehicle for identifying the statement we want to override. We only need to specify the parameter that we need to change unless making that change produces a conflict. For example, if we were changing something from a tape, for example, to a unit equals disk, then that could be a conflict if we don't have a space parameter. So we need to be conscious of that. If we want to nullify a parameter, in other words, we have a value set, but we don't want to use that because maybe it is a conflict or it's contradictory, then we can simply code the parameter with the equal sign and no value associated with it. That nullifies that particular parameter on an override. So what we would have is something like this. Again, looking at the gen proc that we had, we said that what we want to do here is that we want to set our sysout equals to class H rather than the asterisk. So in order to do that, we simply identify the DD statement that we want to change. So within the proc gen proc, we want to change sysut2. So we identify that by saying step1 dot sysut2, and we want to change that to sysout equals H. So when we look at the JCL down below, we can see where the substitution JCL took place for sysut1, and then statement 8 shows where the override occurred. And that indicates that we have overridden a particular statement, and we can see which statement we overrode, because instead of double X's, what we see now is we see an X slash, indicating that we have a JCL statement that has overridden the value that was there within the proc. So let's take a look now in how JCL overrides are going to work with respect to a particular common proc that is used, namely assembling a program. In this demonstration, we're taking a proc that is normally used to assemble a program. And assembling a program basically means that we are taking the source code and we are then compiling it, we're translating it into an object code, linking it out as an object module into a link library, and then from there executing it so that we can then get the results. So this is a process of taking source code, converting it into an executable form, and then being able to see the output from that particular run. And that's what this proc does. And it consists of 3 steps. And in this case here, you can see where we have the execute statement indicating the proc that we want to invoke. Then we have an override here that identifies step C and a sysin statement. Then we have a step L and a syslmod DD statement. And then we have a step G and a date out DD statement. So these represent some overrides. The sysudump is also an override, and it will occur in step G because of the fact that it follows g.dateout. And so as a result, we don't need to specify the G again to indicate that it's an override for the same step. In any case, let's go ahead and submit this and then take a look at what the output looks like so that we can see where the overrides occur and how the JCL was expanded for execution. So I submit this, and now I go and take a look at the output. And when I look at the output here, the first thing is that we can come in and take a look, and you'll notice here that we have all of these X's indicating that this is part of the expanded proc. And sure enough, as we come down here, you can see here's the first step, labeled C, that's the name of it. And so in this case here now, as we look at that first step, we can come down and we can take a look at statement 9, where we have our override, which is a c.sysin. That brings in the program that we want to assemble. Then we have a second step. And now in this step here, we're linking this program into a library for execution. And again, now you can see the override statement here indicating that we are overriding this particular library. Again, you can see the / on the statement 13 indicating the particular DD statement that we are overriding for that purpose. I scroll down further, and there you can see that statement 16 is another execute statement, which is step G. This uses a refer back to identify the program that is being executed. You can see the overrides here for date out and for sysu dump, and those represent the output then that we are using from the execution of this program that we have just assembled. Now the point overall here is to recognize that what we've done is that we have called in a procedure and we have specifically overridden several DD statements to indicate the values that we want. In the first, we've identified where the program is located that we want to assemble. In the second, we've identified the library that we would like to have this module linked into for execution. And then in the third instance, we are executing that particular program so that we can see the results from our run. And those are the 3 steps that this particular proc handles. And this is how we would code using that particular process in order to be able to make changes or to be able to test the program. This is a very simple mechanism that is often used when programmers are developing or testing a new program so that they don't have to store JCL or they don't have to do anything fancy with it. They can just simply make a change to the program, assemble it and link it and run it right away to see whether or not the program works for what they want to do. And so this is, as I said, a very common practice when you're in the early stages, especially of developing a piece of code.